Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following analytical geometry question. We have in the diagram, OCBA is a square with sides 9 units. The line OD is the line 1 over 3y equals to x with D and CB. We are to 1. Describe the quadrilateral ODBA, 2. Determine the area of ODBA, and 3. Determine the coordinates of P, where P lies on OD and AP is perpendicular to OD. For the first part of the question, we have to describe the quadrilateral ODBA. I'm going to highlight that ODBA as shown. To start with, if I go back to the question, we've been told that OCBA is a square with sides 9 units. Because all the sides of the square are equal, and if it's 9 units, I'm going to start with the coordinates of A. A is lying on x-axis, so therefore the coordinates is going to be 9 and 0 because the distance from O to A is 9 units. Likewise, the distance from A to B is also 9 units, and therefore because it's a square, it forms a right angle, and therefore the line CB is parallel to the line OA, which is also lying on the x-axis. So therefore, the coordinate of B will be the x coordinate of A, which is 9, and then the y will be 9. Likewise, to find the coordinates of C, C is lying on the origin, but the y coordinate is the same as the y coordinates of B, which is 9. So therefore, having found all the coordinates of O is 0, 0, because it's at the origin, then we have A 9, 0, B 9, 9, and C 0, 9. You can see that the quadrilateral ODBA, as shown, is a trapezium where one pair of the sides are parallel. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. For the second part of the question, we are to determine the area of ODBA. In order to determine the area, we need to find the length of the parallel sides. The formula for finding the area of a trapezium is half times the sum of the parallel sides times the perpendicular height. I'm going to draw a rough sketch of the trapezium as shown. Then I have the long side. So I have the point D, which is unknown. I have B. I have the point A between A and B, that's 9 units. And also O, between O and A, that's also 9 units. I need to find the distance dB. The coordinate of D will be, I don't know my x coordinates, but I know it has the same y coordinate as B, which is 9. And so therefore, in order to find x, going back to the question, we've been told that OD is the line 1 over 3y equals to x. We've been given the equation of that line. So therefore, we have 1 over 3y equals to x. If I substitute for y, I'm going to have 1 over 3 times 9 equals to x. Therefore, the x coordinate will be 9 divided by 3, which is 3. So therefore, D will be 3, 9. And note that we've been told that OCBA is a square. So therefore, if the coordinate of D is 3 and 9, what that means is the distance dB will be 9 minus 3, which is 6 units. So I'm going to put that in the diagram. I have that as 6 units. I'm going to state how I got 6 units. I have dB equals CB minus CD. And that is equal to 9 minus 3, which is 6 units. Therefore, to find the area, I have area equals 1/2 times the two perpendicular or the two parallel sides, that's your 6 plus 9 times their perpendicular height, 9. I have 1/2 times 9 plus 6, that's 15, times 9. Therefore, the area of the trapezium or the shape ODBA will be 67.5 square units. Let's go to the third part of the question, which says determine the coordinates of P, where P lies on OD and the line AP is perpendicular to the line OD. I'm going to start by reconstructing my diagram. We were told that P lies on the line OD and the line AP is perpendicular to OD. So if I pick a point on OD and I call that P and I draw a line from P to A, then from the question we've been told that AP is perpendicular to OD. So perpendicular means it's from 90 degrees. So therefore the gradient of OD multiplied by the gradient of AP will give me -1. However, because the points O, P, and D are on the same straight line, that means they are collinear. What it means is the gradient of OD will also be equal to the gradient of OP. Therefore, I have 1/3 y equals to x. That is the equation of the line OD. And from there, I have y equals 3x. So what that means is the gradient of the line OD, which is also equal to the line OP, is equal to 3. I got that from the standard equation of a straight line, y equals mx plus c, where the coefficient of x is my gradient. In this case, the coefficient of x is 3, which also serves as my gradient. Therefore, I have MOP times MAP because they are perpendicular lines. If I multiply the gradient, it's going to give me -1. The reason being OP is perpendicular to AP. MOP is 3, so therefore to find the gradient of AP, MAP, which is -1, therefore MAP, going to divide both sides by 3, is -1/3. What I'm trying to do is to find the coordinates of P. So the next step in this case, I've been able to find the gradients of OP. I've been able to find the gradients of AP. The next step is to find the equation of the line AP. So therefore, I have equation of AP. We have that as y equals, we found the gradient to be -1/3. So I have -1/3x plus c. I need a point on that line to substitute in order to find the y-intercept, which is c. So I'm going to use the coordinates A. So I have substitute point A into the equation. Then I have point A, I'm going to put that here, is 9 and 0. That's the coordinate. So therefore, my y is 0. And then my x will be 9 plus c. I have 0 equals -3 plus c. Therefore, my c-intercept will be +3. So therefore, equation of the line AP will be y equals -1/3x plus c. And c, in this case, will be my 3. So note that the line OD and the line AP, they're both meeting at point P. So therefore, the coordinates of the line OD and AP at point P are the same. So what I'm going to do now is to equate the line OD with the equation of the line AP, and then I'm going to get my X and Y. The X and Y will be the coordinates of P. I'm going to use the rearranged equation since I've written it in the standard form, y equals 3x. So therefore, I have OD, it says at point P. I'm going to adjust my calculations. I have at point P, the equation of line OD is equal to the equation of line AP. OD, I have that as y equals 3x, so I have 3x will be equal to negative 1 over 3x plus 3. The first step to get rid of my fraction, multiplying each term by 3, so I have 9x equals minus x plus 9. I have 9x plus x equals to 9. 10x equals to 9. Therefore, x equals 9 over 10. And to get the corresponding y values, I already have y equals 3x. So therefore, I have y equals 3x, which is equal to 3 times 9 over 10, which is 27 over 10. So therefore, the coordinates of P will be x values, that's 9 over 10, and then my corresponding y values, 27 over 10. Thanks for watching. Bye.